A white dwarf in the crystallization phase has been discovered. It will turn into a cosmic diamond. When a star runs out of fuel and nuclear reactions cease, the object cools and gradually hardens. And just such an object was noticed by astronomers in our cosmic backyard, because only 104 light-years from us. The temperature and mass of this white dwarf suggests that it has entered the crystallization stage that will transform the star into a giant cosmic diamond. Most stars entering the last chapter of their lives tend to shrink, and slowly change color. Astronomers refer to these dense objects as white dwarfs. These are the remnants of small and medium-sized stars similar to our Sun. Once they have used up all their fuel in the core and shed their outer layers, the still hot core will begin to cool. This process can take billions of years. These extremely dense stellar remnants still emit thermal radiation and are therefore visible to astronomers. It is estimated that up to 97% of the stars in the Milky Way will eventually turn into white dwarfs, including our Sun. The most massive stars, on the other hand, will end their lives as neutron stars or black holes. As the cooling process brings the stellar remnants to a certain temperature, the originally hot, liquid substance inside the star's core will begin to crystallize and become a hard lump as a result. Scientists have compared this process to liquid water turning into ice. Except that the freezing point of the core in white dwarfs is extremely high, about 10 million degrees Celsius. The process of solidification or crystallization of material inside white dwarfs was predicted 50 years ago. But it wasn't until Gaia's capabilities allowed astronomers to observe enough of these objects in such detail to see a pattern revealing the entire process. Now astronomers have spotted a white dwarf that is part of a quadruple star system. It is relatively close by cosmic distances, just 104 light-years from Earth. Scientists point out that the profile of the dying star, its temperature and mass indicate that it has just entered the stage of crystallization. The description and results of the research have been accepted for publication in the journal Monthly Notices of the Royal Astronomical Society, and are now available in the archive preprint database. The discovery of a cooling white dwarf is not unusual. It is simply the remnant of a star that has used up most of its fuel and then collapsed. However, as researchers have determined, this object is gradually crystallizing. In our paper, we report the discovery of a new Sirius-like quadruple system at a distance of 104 light-years, consisting of a crystallizing white dwarf and 3 other stars, write the researchers led by Alexander Venner of the University of Southern Queensland in Australia. When the fuel runs out, the star's outer material is ejected into the surrounding space, and the remaining core collapses into an ultra-dense object, roughly the size of the Earth, or the Moon, but of much greater mass. Then the crystallization process begins. In the case of stars whose core consisted mainly of metallic oxygen and carbon, the atoms of these elements inside the white dwarf stop moving freely and form bonds, arranging themselves in a crystal lattice. During this process, energy is released and dissipated as heat. However, we should not hope that we or our distant offspring will see it. This process is incredibly slow and will take billions of years. But will the object actually turn into a diamond? Scientists are not entirely sure whether the crystals formed in the white dwarf can be called a diamond. The density of white dwarfs is over 1 million kilograms per cubic meter, while the density of diamond is only about 3,500 kilograms per cubic meter. Caring fathers in the world of amphibians. We are used to thinking that in the animal kingdom juveniles are cared for by mothers, pairs of parents, or sometimes the whole herd, often supported by older siblings, and the role of the male is limited to transferring genetic material and maintaining the territory where the females reside. Meanwhile, the father's participation in the care of the offspring can be very large, and in nature the role of the male is often crucial in the process of rearing the young. When talking about fathers' care over their offspring, many people associate seahorses, i.e. sea fish from the Syngnathidae family, in which males incubate eggs in a special bag. Regardless of the systematic group, parental care, both exercised by the father and the mother, has one goal: to increase the survival of the offspring, of course at the expense of the parents. Among modern living amphibians, it is estimated that about 5% of them display various forms of parental care. Described species, i.e., over 400 species, from at least 31 families and different orders occurring on different continents. This means that the parental care strategy has developed many times and independently in the course of evolution. 5% is relatively little, however. It should be taken into account that our knowledge of the ecology of many exotic species is small, therefore the share of this type of behavior is undoubtedly significantly underestimated. Interestingly, the amphibian model is dominated by the single-parent model, and the joint care of the male and female is a real rarity. In tailed amphibians, e.g., lungless salamanders, it is the female who mainly takes care of the offspring, while in more than 2/3 of the frogs it is the fathers who are the main caretakers. The participation of fathers in caring for their offspring may last from several to several dozen days. Most often, care is manifested in the transport of eggs, tadpoles, including taking care of the conditions for proper incubation. A popular example of care can be observed in the fabulously colorful tree frogs, Dendrobatidae, small amphibians popular in terrariums, zoos or nature films, in which the transport and care of tadpoles is a very common behavior. This varies from species to species, with both males and females taking care of it. Fathers often stay close to tadpole development sites until they metamorphose. However, this type of behavior is not only in the exotic tropics. Equally interesting can be observed in the elite obstetric gnats found in southeastern Europe. In this species, the male, after fertilizing the eggs laid in strings, wraps them around his hind legs and then carries them on land until the tadpoles hatch, which lasts about 30 days. The male Darwin frog Rhinoderma darwinii, a critically endangered species from Chile. After about 20 days of incubation of eggs on land, swallows the developed larvae, which end up in an extremely well-developed vocal sac. During this period, tadpoles feed on the secretion produced by the skin. This is an unusual example of patrotrophy in the animal world.